Climate change is impacting our planet and society as never before. This is why the European Space Agency is using Earth observation satellites to measure and determine the consequences of human activity on a global scale. One of the most damaging effects seen from space is the global trend of melting ice on our planet. This ice is called the cryosphere. It's comprised of ice sheets such as the Antarctic, sea ice like in the Arctic, but also of glaciers and permafrost regions. While the melting of the ice sheets of Antarctica and Greenland are the best known examples, satellite measurements indicate that in the last half-century, glaciers across the globe have also lost a significant amount of ice.
Over the course of the last century, we've seen quite dramatic changes in these different elements of the cryosphere. Notably, we've seen significant losses in Arctic sea ice. We've seen decline in the volume of ice locked up in glaciers, and we've also been witnessing changes in the large ice sheets, Greenland and Antarctica. The consequence, of course, is that sea level is rising as water is transferred from ice on land into the ocean.
While half of the sea level rise comes from thermal expansion caused by warming ocean water, melting glacier ice is the second largest contributor. Research shows that over the last 50 years, glaciers have lost more than 9 trillion tons of ice, raising the sea level by 2.7 centimetres. Although yearly data measurements may fluctuate, a global trend is visible whereby the rate of ice loss has increased. At the current rate, about 3 times the volume of all ice stored in the European Alps is lost every year. This corresponds to around 30% of the current rate of sea level rise. While rising sea levels are threatening many coastal areas across the world with severe flooding and more extreme storms, melting glaciers will also impact people living downstream of these glaciers, who depend on this seemingly eternal water resource, especially during the summer or dry season.
Glaciers have a huge impact on the population on Earth, in particular in Southeast Asia, where millions of people are dependent on mountain water resources. During the summer season, we see the melting of the glacier and the mountain snowpack. This, of course, releases water which is used for irrigation in the fields. It's used for generating hydroelectric power, and it's also used for drinking water. And so we're very much concerned with how climate warming has an impact on the seasonal stream flow and the way in which the water resource can be managed in the future.
From space, several of ESA's Earth observation satellites and the EU's Copernicus satellites monitor our global ice cover. Cryosat, for instance, is dedicated to measuring the thickness of polar ice and changes in the ice sheets of Greenland and Antarctica, whereas Sentinel-1 is used to track sea ice. With this kind of satellite data going back more than 25 years, scientists can calculate the volume of ice loss on a global scale. It also furthers their climate models and allows them to make predictions about the rate and impact of future ice loss. Another worrying aspect of the global thaw is the impact it has on permafrost. This is the almost permanently frozen ground around the Arctic regions. Scientists are concerned that when this ground thaws, methane that was trapped in the soil will be released into our atmosphere, amplifying the greenhouse effect. But it's not the only self-replicating effect being triggered by the melting of snow and ice.
We talk about the impact of melting snow and ice surfaces in terms of what's known as the albedo effect. When snow is dry, it's very reflective, and of course that helps to reflect sunlight back out into space, and the consequence is we can reduce the amount of melting this way. However, as ice and snow melt, the albedo and the reflectivity becomes lower, and this has the effect of absorbing more of the solar energy. This contributes to further warming and further melting. And so it's a runaway progressive effect caused by the reduction in the albedo.
It's clear that monitoring our planet's cryosphere is of great importance as it influences the lives of millions of people. The European Space Agency recognises this and already looks forward to the future. 3 of the 6 high-priority candidate Sentinel missions are aimed at addressing urgent climate and operational user needs related to ice sheets, snow and sea ice. With these tools, from space, we can look at our planet and see which policies are needed to slow the global thaw.